Hi, this is a video about chemical reactions of 5 types of reactions and then also being able to predict the products. So we do have our 5 types of reactions. And again, I think you covered this in 9th grade, but so synthesis is always going to be, 2 things on the reactant side and only 1 thing on the product side. So only 1 product here. Example, I've got sodium plus chlorine. Chlorine's one of the diatomics. And then they're going to form sodium chloride. And I need to balance charge when I write the chemical formula for this. Sodium is +1, it's in group 1. Chloride's -1, it's in group 17. And then we'll get into balancing. Actually, you guys know how to balance, so we could put a 2 and a 2. Decomposition is essentially the opposite. You have 1 compound right away breaking down into pieces. So, for example, water will decompose when you apply electricity. This is called electrolysis. It'll break into its elements, hydrogen and oxygen. These are both diatomic, part of the Brinkelhoff. So then I would balance with a 2 and a 2. Single replacement. This is where you're going to have a single element, a compound. Then you're going to, so this is, I always call this one lonely guy. He goes in and takes, like these guys are dancing. He takes this guy's place, makes a new lonely guy, and a new couple. So it's always going to be compound and element on the reactant side, compound and element on the product side. So for this example, I've got aluminum, lonely guy, plus copper 2 chloride. That's the couple or the compound. Aluminum's going to go in, kick out poor copper. Now copper's a new lonely guy. Aluminum's going to go with the chloride. I do need a balanced charge. So I know aluminum's +3 because it's in group 13. Chloride's -1. So it would be AlCl3. Then I'm going to balance. I'm going to want to have 6 chlorides. So I'm going to put a 2 here and a 3 here. Now I'm going to want 3 coppers here. And I have 2 aluminums, so I would need a 2 here. So this can also happen with, this was a metal, taking out a metal, kind of like if you were dancing, the guy would replace the other guy. You can also have the girl, or the non-metal, so chlorine, lonely girl, sodium bromide, it's the happy couple. So she is going to take out the other she, or the non-metal, takes the non-metal out. So then we get new lonely girl. She's diatomic though, plus sodium. Metal goes first, just like the guys lead when you dance. Metals go first in the compounds, sodium chloride. Couple more. So I have aluminum sulfate. This is a double replacement. So it's good if you could practice. You could pause and see if you can write these compounds. You're just balancing charge. They're ionic. Before I do that though, a double replacement is going to look like this. So I think of it as the metals, or the cations, switch spots. So it's kind of like dancing, but you switch partners. So this guy goes and dances with the girl D, and C goes over and dances with the girl B. So if I look at this one, my aluminum is going to switch with my barium. And when I come over here, I do have to balance charge. So barium is +2, sulfate is -2, so they're just in a 1-to-1 ratio. Aluminum is +3. I'm not bringing the 2 with because that 2 is not part of the aluminum. It was part of the sulfate to balance charge. Aluminum's +3. Nitrate is -1. So I would need 3 of these to balance. Charge, And then I can balance the equation too. I won't do that this time just to save a little bit of time. And then we also have the last type of reaction is combustion. And when you have a combustion reaction, you have carbon with some amount, hydrogen, sometimes oxygen. And when something burns, it needs oxygen. And it's always going to form carbon dioxide and water. So these three things are constant for a combustion reaction. This can vary. So let's go a little bit deeper into each of the types of reactions now. And I would take good notes on this so that you can use them when you take the assessment and when you do your homework. So synthesis, you can have synthesis reactions between metals and oxygen, and they form metal oxides. So for example, lithium, the metal, will react with diatomic oxygen, and then it'll form lithium oxide. So my thinking bubble here, I'm not showing it, but I'm thinking, oh yeah, I know lithium's +1 because it's in group 1. Oxygen's -2 because it's in group 16. So if you haven't written those above your periodic table, I'll just kind of remind you, this doesn't look quite right, but you're going to want a +1 over group 1, +2 over group 2. Then you get over here to 13 is +3, skip 14, 15's -3, 16's -2, and 17's -1. And then you can balance this. I'm going to balance the oxygen. So I have 2 oxygens and 2. And now I have 4 lithiums. So this is a metal plus an oxygen makes a metal oxide. Here's another one, calcium. So I would pause and try these before I do them and then see. So calcium reacts with oxygen. And it's going to form calcium oxide. Again, my thinking bubble that you don't get to see is that I know calcium is +2, oxygen's -2. They already add to 0. They're balanced in charge, so it's just a 1-to-1 ratio. Balancing the reaction, I'm going to put a 2 for the oxygen and a 2 for the calcium. Nonmetals can also react with oxygen to form oxides. So, for example, hydrogen can react with oxygen and form dihydrogen monoxide, which is water. So a nonmetal plus oxygen forms a nonmetal oxide. Sometimes we'll call it that. So we'd also balance this with a 2 for the oxygen and then a 2 for the hydrogen so that we have 4 total. The metals will also react with group 17 elements to form ionic or covalent compounds. I can't think of when it would be a covalent, but let's just do the one I have. So sodium can react with chlorine gas. So remember, this is a Brinkelhoff. Group 17 are in, a big part of the Brinkelhoff. So we know these guys are in group 17, 17, and 17. So these two will react, and then we're going to form the ionic compound, sodium chloride, thinking bubble. Sodium is plus, chloride's minus. That's how I know the formula. I'm going to balance the atoms by putting a 2 and a 2. Oxides of active metals, so if it's a metal oxide of an element in group 1 or 2, they can react with water and produce a metal hydroxide. So calcium is in group 2, oxide, +2 -2, reacts with water. You can write water H2O, or you can write it as HOH. And then that's going to form a metal hydroxide. So my thinking bubble's up here. The metal is calcium. hydroxides on my pink polyatomic ion chart. So to balance charge, I need 2 of these. So the formula would be CaOH parenthesis 2. So if I try to balance this, I have 1 calcium, 2 oxygens, and 2 hydrogens. I have 1 calcium, 2 oxygens, and 2 hydrogens. So it is actually balanced already. Oxides of nonmetals or nonmetal oxides will react with water to form oxyacids. So sulfur dioxide is a nonmetal oxide, so sulfur is a nonmetal with oxygen, reacts with water, and then they form an acid, and the acid is going to be H2SO3. So I'm really just summing up the sulfur, oxygen, and hydrogen. And you can see that that is an oxyacid. It's sulfurous acid. Metal oxides and nonmetal oxides can react. So here, sulfur dioxide is a nonmetal oxide. Calcium oxide is a metal. Remember, metals are to the left of the stairs. Oxide. They can react to form a salt. So they can react to form calcium sulfite. So again, I'm just really putting together the metal and then the nonmetal and then the oxygen. Decomposition. So decomposition is when you have that one substance breaking down. So I can have a nonmetal oxide like water break down into its elements. A lot of times decompositions need electricity or they need heat, and then they'll just break apart. You would want to balance this. We'll keep going. I'm going to get through the decomps and then I'm going to pause the video and start over for the other 2 types. So decomposition, there's a lot of these fun ones. Metal carbonates can decompose into metal oxides and carbon dioxide. That means, so if I have lithium carbonate, I'm going to do it as a word equation first. I'm going to get a metal oxide, so I would get lithium oxide and carbon dioxide. Now I'm going to write it as a chemical equation. So Li2CO3 will break down and give me Li2O minus 2 plus 1. That's how I know the formula. And then carbon dioxide. And this is already balanced. Metal hydroxides. So this is the opposite of those synthesis reactions. So this one is. So if I have a metal hydroxide, aluminum's my metal, hydroxide will break into a metal, which is still aluminum, oxide. So I'll get aluminum oxide and water. So I would write that as AlOH3. This is -1, this is +3. Breaks down into Al2O3 plus water. And I'm not going to balance it just for the sake of time. One last decomp, and then I'm going to pause the video, and then I have a little bit more decomposition, single replacement, double replacement, and combustion. So this is metal chlorate. So in this case, it's the metal's potassium chlorate. They will decompose into a metal chloride, so that would be the metal potassium chloride and oxygen. So if I write that out, it's going to be KClO3, because chlorate is ClO3 -1 on my pink sheet. Potassium is +1 in group 1. Then I'm going to get potassium chloride, +1, -1, plus oxygen. Oxygen's diatomic by balance. And I'm going to stop the video and I'm going to start at part 2.